All right, well, we're going to continue with rational expressions. This time we are going to deal with adding and subtracting. So of course, before you can do this with algebraic expressions, you have to know how to do this with numbers. So let's take a look at 2/3 plus 3/4. What you don't do is add the numerators and add the denominators. Do not do that. What you do need to do is think of this as 2 out of 3 pieces. And if I were to, well, I will take the time to do this. Think of 2/3 as here's my whole. So I'm going to section it into 3 pieces. Let's pretend like they are equal sizes. Plus 3/4. So I'll chop this one into fourths, again, pretending they're equal circles and everything. And we want to combine these together. Well, in order to do that, you have to have the same size pieces. So you have to figure out, how many pieces would I have to slice each of these into so that I could have the same size pieces and combine them together. And that's the idea of adding fractions, and that's the idea of finding a common denominator. So for the in order to have the same size pieces, I would have to have them in 12s because 3 and 4 both go into 12 evenly. So then, in order to get this to be a 12, I'd be multiplying by a 4. And whatever you do to the denominator of fraction, you have to do to the numerator of that fraction. So I get 8/12. Then here, I'm going to multiply by a 3 to have that be a 12. Again, I'm getting the same size pieces over here. So whatever you do to the denominator, you do to the numerator. So I get 9/12. And now I add those together. Now I don't add the denominators because I still have 12s. If I have 8/12 plus 9/12, now I have 17/12. You are allowed to leave your answer like this. It is an improper fraction. It cannot be simplified. That is fine to leave it that way. If you want to change it to 1 5/12, you can, but you'll generally see me leave something in an improper format. Okay, so if you have a mixed number, what I always do in that case is I just carry over the whole number and I set this up so I can find my common denominators. Now, if I have these two, I can't use the 8 because 6 doesn't go into 8 evenly. So what I generally do is I think, okay, well 8 times 2 is 16. Well, 6 doesn't go into 16. 8 times 3 is 24. 6 goes into 24, and that's how I kind of figure out my least common denominator. So here 8 goes into 24 3 times. You multiply 3 by the numerator, you get 9. 6 goes into 24 4 times. You multiply here, and you get 20. And now you can add them together. So I get 5 and 29/24. Now, whereas I said this I would leave improper, this is a little awkward because I already have a mixed number. So 24 goes into 29 one time. I'm going to add the 1 whole time to the 5. And I had 5 left over. So this would be the best answer that you should give. For subtraction, start off the same way. You're going to find your common denominators. In this case, notice that 5 goes into 15 evenly, so 15 is my common denominator. So I don't have to change this. 5 goes into 15 3 times. 1 times 3 is 3. Okay, the reason I'm allowed to do this is I'm really multiplying by 1 because I'm multiplying by 3/3. And remember that 1 is the multiplicative identity, so you can multiply by 1 and not change the value. So remember, I am subtracting. Now, the problem we have here is I have to do 3. I'm taking away 11. I don't have enough, so I have to borrow. So I'm going to make this 12 and 11. I'm going to change the one that I borrowed into 15/15. So I'm going to change this 1. I took away 1 whole, but I'm going to change it to 15/15. So now I really have 11 and 18/15. You can't just put a 1 in front because we're not dealing with intents. So you do have to think about that. And now I can subtract. So 18 minus 11 is 7. And I get 7 and 7/15. Okay? So now let's see how this works if we are dealing with algebraic expressions. Well, here I still have to find a common denominator. So I take a look at my 3 and my 4, and hopefully you can see that my common denominator is going to be 12. So I'm going to multiply the denominator over here by a 4. But that means I have to do the numerator by 4 also. By the way, this should have said simplify as my instructions. Okay, over here I'm multiplying by 3, so I'm going to have to multiply the numerator by 3. So what do I have? I've got 4 times the quantity c plus 2 minus 3 times the quantity c minus 4 all over my common denominator of 12, because now I can combine it together. Still not done though. I'm going to need to distribute my 4 over here and distribute my minus 3 over here. So we end up with 4c plus 8 minus 3c. Be careful here because it's going to be a plus 12. Remember this minus sign, the negative is getting distributed as well, all over 12. And then we have a little bit of simplifying to do. I've got 4c minus 3c. I can combine that to c. And I'm just combining like terms now. 8 plus 12 is 20 all over 12. Now be careful that you don't fall into the trap and think, oh, I can reduce this by 2. You can't, because the 20 is part of a sum or a difference. You are done. Okay, so for this one, now remember we've got to find a common denominator. Well, think about when I had, like if I had a 3 on the bottom and a 4 on the bottom. Notice that we multiplied those together and we got a 12. Well, here I have a y minus 2 and a y plus 1. Well, we're going to multiply them together to find the common denominator. So over on my left fraction, I'm going to be multiplying the y minus 2 by a y plus 1. Whatever you do to the denominator, you do to the numerator. For this fraction, I'm going to multiply the y plus 1 by the y minus 2. Whatever you do to the denominator, you do to the numerator. Remember, again, that's like multiplying by 1. Okay, so I now have a common denominator. Remember the order? Well, I wrote them in the same order anyway. But for multiplication, it's commutative. The order wouldn't matter of the factors. So up here, you can actually FOIL this. I'm going to do that. Remember, you can multiply this in a box. You can do first, outside, inside, last. I'm going to do that. So I'm going to have y squared. The outside is going to be plus 3y plus y plus 3. And this is plus, so I don't have to worry about the whole distributing a minus sign or anything. We're going to have y squared is first, minus 2y is the outside, minus 3y is the inside, plus 6. So now you're going to do a little bit of simplifying. I've got a y squared plus a y squared is 2y squared. I have a 3y, another one, so I have a 4y, minus 2y is 2y, minus 3y is minus y. And I have a 3 plus a 6 is 9. You could leave this bottom part in factored form, or you can multiply it out and we would have y squared. The outside is negative 2y and plus y, so we get negative y, and then a minus 2. Okay, so if you want to multiply that in a box, remember you can do that this way. So if you multiplied y plus 1, y minus 2, so if you preferred to organize your work that way, that's fine. I tend to like the FOIL method because I can do that quickly and come up with my answers. So this would be your simplified answer. Okay, now there is always the possibility that my numerator could be factored and I would leave my denominator in factored form and then I could see if anything can cancel. So actually let me just take a minute to make sure. I'm going to take the numerator now. We would have an 18 if I was attempting to factor this with a modified diamond. I'd have an 18 here and a minus 1 here. So I'd be looking for two numbers that multiply by 18 and the difference of them is a negative 1, and which would mean both of them were negative, and there's no way to do that. So it's not, the numerator is not factorable, so I would put my answer like this. Okay, now notice I have x's and y's. No big deal. So if I want to find a common denominator, I'm going to multiply these together. So on this side, I'm going to have a y plus 1 and a y plus 1. Over here, I'm multiplying the denominator by an x plus 1 And to keep it, remember again, I'm multiplying by 1, so that's why I'm allowed to do that. Now I have to distribute, so I'm going to have an xy plus x, and since it is plus here, I'm going to have an x, I'm going to write this as xy because it's commutative and I prefer writing it that way, and y times 1 is y. My common denominator, x plus 1, y plus 1. Combining like terms, I'm going to have, it really doesn't matter how you organize this. I'm going to organize it as an x plus 2xy plus y. And my denominator, I'll go ahead and I'll multiply it out. So I'm going to have xy, and then the outside is plus x plus y plus 1. And honestly, it really doesn't matter. If you left it in factored form, that would be okay. This actually can't be simplified. I mean, you could change the order around if you wanted to. You cannot cross out the x's and the y's because they are part of a sum or a difference. So be careful not to do that. Next one gets a little more complicated. Okay, so now notice I've got this b down here. Ignore it for a while. I mean, you can't completely ignore it, but just focus on this part up here. I have 2 over a plus 7 over b, so I need to find my common denominator, which is going to be a times b. So I'm going to multiply this by b over b and this by a over a. So when I do that, I'm going to have 2b plus 7a over AB, because that's my common denominator. Remember that this means divide by. So I'm going to divide by B. If you want to, you can do it as divide by B over 1. Remember from yesterday, we talked about when you divide with fractions, you're going to change it to multiplying by the reciprocal. So I'm changing this to 2B plus 7A over AB times, and I'm going to flip over this and have 1 over b. Okay, now you will notice, now had the AB been on the top, I could have canceled the b's, but here I can't. There is no canceling to do. So I multiply straight across, and I'm going to put the 7a first, just because I like to. 7a plus 2b, it's kind of conventional to put them in alphabetical order. And here we're going to have ab squared. And that's my answer. I'm doing kind of a few of these examples. I want to do enough of them so you can kind of get the idea of how to do these. So here, again, I'm going to start with the numerator and simplify that first, worry about this later. So I'm going to multiply this by a over a and this by b over b. So now I have a squared minus b squared over ab. And remember, this fraction bar means divide by. I'm going to change it to this, divide by a plus b over AB. Okay, so now this is the difference of two squares. So I'm going to factor that because I can kind of see what's going to happen over here. I have this a plus b because remember I'm going to flip it and change to times. So I'm going to do the difference of two squares. So we get a plus b times a minus b over AB times, because I'm changing divided to times, flip the second fraction, the reciprocal, we get AB over A plus B. So now the A's cancel, the B's cancel. So this AB cancels out because A divided by A is 1, B divided by B is 1. And then this A plus B, I'm canceling out the whole thing. A plus B goes into A plus B once. And over here, same thing. So look what I have left. A minus B. So this whole thing simplifies to A minus B. Lots of math involved in that, which is why that factoring flowchart was so important and all the little different ways of factoring, because you need to be able to recognize that the difference of two squares. You need to recognize that pattern. Now, sometimes these will show up in word problems. Here we have an example. Aaron wants to mulch his garden. His garden is x squared plus 18x plus 81 square feet. One bag of mulch covers x squared minus 81 square feet. How many bags of mulch does Aaron need? Now, I know you might look at this and say, well, when would you ever have your area written out like this? Well, it is possible that if you had, like, say you had your rectangular garden and you were going to call this x or x plus 3 or whatever, you had it in terms of a variable expression, because then maybe you want to know, well, what happens if I have this size garden, or what happens if I have this other size garden? And you can change your dimensions really easily and calculate the different amounts of mulch. So a landscaper might want to be interested in doing something like that. It probably would be on a spreadsheet. So it is possible that you could have to do something like this. Now, if one bag of mulch covers this amount of the area, and we want to know how many bags of mulch he needs, hopefully as you read this, you can see that this really boils down to just being a division problem. So we're going to take x squared plus 18x plus 81, and we have to divide that by x squared minus 81. So what I'm going to do, this is kind of like what we did yesterday. So I'm going to factor. My numerator becomes x plus 9 times x plus 9. It is a perfect square trinomial. You could do a diamond problem, or just kind of, if you do, once you do them enough, you just start to see that. Here you really want to recognize the difference of two squares, x plus 9 times x minus 9. Notice that these can cancel because it's now factored form. So my answer becomes x plus 9 over x minus 9. And that would be bags. So that's how many bags of mulch he needs. And so we still have, if we were solving, or changing the dimensions, then we would just change the number of bags by substituting the value in. Last problem. So here's kind of we're putting both days together. So we have adding. I guess I didn't have subtraction on this one, but we do have addition. And well, you know what? We can change that. I'm going to do that right now. So now I have no idea how this problem will go. I may have made it really complicated. We'll find out. So I'm going to start by just concentrating on this numerator here. So I'm going to multiply this side by c plus 1 over c plus 1. I prefer putting in parentheses because that's going to help you when you remember, hopefully, to distribute. And over here, we're going to multiply by c plus 2 over c plus 2. And I'm going to put parentheses here. Notice that's going to have to go in a box. And I'm going to have to be really careful with the minus sign. So next thing up, we're going to have our denominator of c plus 1 times c plus 2. And here I'm going to distribute, so I'm going to get 2c squared plus 2c minus, and I'm going to be careful with that. I'm going to multiply this out, but I'm going to leave parentheses here because then I'm going to distribute the negative sign as a separate step. So I'm going to have c squared, that's first. The outside is positive 2c and the inside is a negative c when I do this. So I'm going to have a plus c. You can also multiply this out in a box if you prefer that, and a minus 2. I still have this down here, and I probably should rewrite that so I don't forget it. Okay, so now I'm going to take care of this minus sign. So I'm going to have, I'm just going to write it up here so I don't have to rewrite it a lot of times. 2c squared plus 2c minus c squared minus c plus 2. Being really careful to distribute all that. Now I can combine like terms. So 2c squared minus c squared is c squared. I have a 2c minus c is c, and a plus 2. Over, I'm going to leave this factored, c plus 1 and c plus 2. Now, this is divide. I'm going to change it to times and flip or do the reciprocal here. So I'm going to have c plus 1 and 2c plus 1. Notice I can cancel these. Now, I should make sure that this can't be factored. And if I did a diamond actually I can see that it can't, because the only way you can get a c squared is c times c. The only time you can way to get a 2 is 2 times 1, and that's not going to give you the correct middle term. So chances are if I had left this with a plus, it would have done, it would have canceled out maybe nicer. But here we're going to have c squared plus c plus 2. And you can leave this in factored form or multiply it out. I'm going to multiply it out because this one is that way. So I get 2c squared. The outside is c, the inside is 2c, or 4c, I'm sorry. So we have plus 5c and then a plus 2. So I think I would probably leave my answer like this. Don't forget, you can't cross out the 2's because it is part of a sum or difference, and that would be your answer.